My name is Olga Pikelnaya. I work for the South Coast Air Quality Management District, which is a local air quality agency. I will give you a very brief introduction to the history of the air pollution in Los Angeles and why it's important for us to do this project in Los Angeles area. So Los Angeles historically has been a very polluted area in the United States and one of the most polluted cities in the United States. It started in the beginning of the 20th century primarily because of the explosion, simultaneous increase of population as well as increase of industry. And actually, even in I like to show this little slide of the Optimists Meeting Club in 1954, which actually made made national news, which they show a number of members wearing gas masks, and the banner in the back of the room says, "Well, wait until 1955, we might not even be alive." So it was actually very clear that air pollution is becoming a great issue and a great problem in Los Angeles basin. And so I was essentially created to combat air pollution. And over the last decades, we made a great progress combating air pollution and making air cleaner for everyone to breathe. I like to show this slide here to show how we track our progress in combating air pollution for two pollutants: ozone, which is a very big concern in Los Angeles, as well as PM 2.5. And as you can see over the years, the trend is downward going trend, primarily showing that we are on the way to meeting air quality standards. However, much more work still needs to be done. Another way how we track the progress of the air pollution is by doing every 4 years a multi-toxics air quality study. And for example, on the right-hand side, you see two maps that we create for this study in 2004 and then back in 2012 that shows a significant decrease in the air toxics risk in the basin. But again, more work needs to be done. The way that we usually do air quality and communicate it to the residents of the LA basin is by producing maps of the air quality index, which is a composite of our monitoring done by regulatory monitoring over the 40 stations distributed all over the LA basin, as well in studies that essentially take into account the metrology and the various pollutants in the basin. And on top, you see an example of this air quality index that we produced, which is done on the hourly basis for November 26th of this year. And you see that it'll give you an indication how the air quality in the basin is. However, it's very coarse resolution, so you can get an idea for the regional air quality, but you're not going to get a resolution for your area where you live, where you go to school, where you go to work, or where you plan to do your exercises. So that's where the very attractive and very useful tool to get a little bit more granular information of what your air quality is on your local scale. And on the bottom, I show the screenshot for the air quality index just for PM 2.5 for one low-cost sensor network called Purple Air that we're actually planning to use in our project. And it shows approximately the same area that the AQMD air quality index. And you can see that overall, it captures the same trends. However, there is this more granular variability that you can see on the Purple Air map that you don't necessarily see on the regulatory network. So that's why, low-cost sensors can help provide this most time and space resolved information to complement what regulatory sensors are doing. And I'm going to turn now to my colleague, Brandon, who will be talking more specifically about air quality sensors.
Thank you, Olga. Yeah, South Coast Air Quality Management District, and I will talk to you shortly about low-cost sensors and a specific group here at South Coast called the Air Quality Sensor Performance Evaluation. Next slide. Low-cost sensors are a lot of applications. They are getting increase in use. You can see that in the literature, and also just viewing some of the community-based and open source platforms that use low-cost sensors. We can see that low-cost sensors are being used a lot more throughout the United States and throughout the world. They're used for monitoring. They're also used to supplement air monitoring networks. So governments run air monitoring networks, and the low-cost sensors can be put in between, as Olga had talked about earlier, to increase that spatial and temporal resolution of our current monitoring network. And if we're looking to expand our air monitoring network, we can use low-cost sensors to determine where's the best place to place a new monitoring station. Low-cost sensors also can be used in hotspot identification or on mobile monitoring to place sensors on a car and be able to find out which locations within a city have higher concentrations than other locations. They also are great tools in science education for high school, middle school students to play with these sensors and build out applications and learn from using these low-cost sensors. People use them in qualitative personal monitoring, so they can be attached to a person as they walk around, and they can see whether the pollution is higher at work or higher in the vehicle as they're driving or higher at home indoors. And they also work well for exceptional event monitoring like wildfires. And we have this chart here on the right, which talks about data quality and the need for higher data quality for different applications. And as Prakash mentioned earlier, the ambient air monitoring network is made up of regulatory monitors that are reference grade. These are very large, very expensive monitoring, and these are used to determine legal compliance. And so you need to have a high data quality, and it's a high cost instrumentation. And you can see the box here, which kind of outlines the community-based monitoring, supplement air monitoring network, and the screening for hotspots. That's kind of the spot where low-cost sensors work. And there is increased measurement error in these sensors. They're not perfect. They're not as high quality. They're not as accurate as the reference monitors. But they do work well to provide additional information and air quality information for these types of applications. And one of the things that Olga talked about as well is being able to make those informed decisions, whether to go for a run in the morning or the afternoon, based on up-to-the-date, hyper-local air quality information. That's one of the these low-cost sensors, and they can be deployed in large networks as a result of their low cost. So quickly look at why we're choosing the Purple Air sensor. We have this Air Quality Sensor Performance Evaluation Center here at the South Coast. We've evaluated up to 35 particulate matter sensors so far, and this sensor is chosen for this project for several reasons. One, it performed well in the field in the laboratory. Those results are available on our website at aqmd.gov /AQSpec. Feel free to results for the 34 other sensors that we evaluated in this program. The sensor that we have chosen, the Purple Air sensor, is an open source hardware and also open data access So it works great for a community science-based project where we can a data platform for our community members to use while they are engaged in this project. And these are the reports that are available online. I encourage you to go there and check out those websites. Look at the purple air quality sensor. The sensor is made up of three primary components. The first is the raw sensor. That is actually housed in a 2.5-inch diameter there. So it's a small sensor, it's easily mountable. And then the power supply is a 15-foot power supply, and that's outdoor rated. And then the third component would be the USB to micro USB cable. The sensor measures particles in the air, and it will differentiate between size fractions. So it measures the larger particles, PM10, the smaller particles that Prakasha talked about in comparison to the human hair, PM2.5, and as well even PM1. The requirements for installing this sensor and using this in a citizen science home, you're going to need to have access to Wi-Fi. You're going to need to have access to power, so it plugs into the wall. It has about a 15-foot cord, and then a location to install this sensor. This is typically installed on the outside fascia of a home. So you need to have that external power access and then Wi-Fi strong enough to reach that sensor so it can be connected to your Wi-Fi. There's 3 steps to install this sensor and to get it on the network and so that the data is visible on the map. First is to find a good location at your home and residence and install the sensor. It takes 1 screw at the top of the sensor. There's already a pre-drilled hole in the mounting bracket. Second part is to configure your sensor to your personal home Wi-Fi network. And the last step is to register your sensor on. And with that, I will just show this map one more time that Olga has already shown, which is the purple air map. The data is live streamed into here. It updates in very near real time. So you get about new readings every 40 seconds. And this is updated in real time.